Howdy folks, I'm Keith Bowen and this is Hard Rock University. Today I'm going to show you how to survey in a drift or a tunnel using, again, simple hand tools. Now, to make this easier to see, we're doing this behind the hotel and we're going to use this alley as our simulated drift. We've got about 3 survey points down there. Now, the first thing you have to do is determine the length of the tunnel or the structure you wish to survey, because that tells you what scale you can use and still get it all on one sheet of paper. And it's much simpler and more accurate if you do it on one sheet of paper. Now, right here we have the simulated survey point at the portal. The adit goes back through the camera. This would be looking out of the portal. And first thing you want to do is orient the survey so that you know the actual directions everything is going, not just relative angles. So I'm going to assume, for the sake of the exercise, that that telephone pole down there is due west of us. So what you do is you would take your Home Depot plane table, get it somewhere approximating level and stable. Doesn't have to be perfect. Wow, that's really unstable. Okay, set it over your point. Now in this case, I'm just orienting the paper east-west. So I take and make something that's easier to see and come down here and visually sight along it to that telephone pole. Now I have oriented the paper. I need to have an initial point. I'll just make an initial point right there. And this is the orientation line there. Now, oops, I just moved it. This is the one negative of this. Yeah, especially if it does that. So let's give it 3 points of contact, if we can. Wow, that's pretty unstable. Oh, this one looks better. There we are. Instability fixed. Okay, now at this point, what you do is measure to the next point. Now you can measure the distances between all the points, which you previously laid out as sight lines. You have to be able to see from one point to the next. I'm simulating a curve in the tunnel where you can't see around it. And so it's been broken up into several sight lines. That you have to do beforehand and mark them. Then Eva, go ahead and take the other end and grab one of those cans. Now Eva's going to walk out there and measure the distance, because we're going to build an exact scale replica of the tunnel on the piece of paper. Okay, pull it tight. You can just grab the tape and pull it tight, but just snug it up. A little tighter. Okay. What's the distance? 61.5?
Yeah.
Okay. Now put the can down there so I can see it. Now right behind it in line. There you go. Doesn't have to be on top, but in front of or behind it. I like millimeters when possible because it makes the math simple. If you got like 50 feet per inch and the inch is broken up into 16 segments, you got to do math. Pain in the ass. So you write down the 61.5 feet so you don't forget it. Now we have to shoot the angle. And I find it's very easy to fudge things up. So put the pencil right there, sight down that, and then draw a line. Now this line is that line in direction, down on the paper again, and now we measure 61.5 feet, put a point, and there we are. So this is the portal. This is west. And now we move this whole apparatus to the next one. When we were doing the dump, we were doing it from one spot because we could see everything from one spot. In a tunnel, that's not going to work. Pull this away. Put a sight point here. Now what I was doing underground was I was leaving a flashlight laying on the ground. Anything that you can see will work. Now at this point, again, if you lay this next to your line, it just makes it easier to see. And we don't know which way to turn it this way, so we have to back sight. In order to orient this, we have to back sight to that point there. Okay, on paper. So this line here is now oriented along that line there. That point is that can there. This point is the point we're sitting on. Now we just need to get the direction to the next point. Hold this firmly down. Put your pencil there. Sight to your next point. Draw the line. Underground, usually Eva would be ahead of me and holding the tape. I've got her holding the camera now. And as you can see, that was just a little bit off. So I will make a new line that goes right through the point. Now, she'll go ahead. Yep. Keep going, keep going. And then normally she would just stand over the point and I would shoot on her helmet light. Okay, distance?
41 feet, 10 inches.
Okay, call it 42 feet. Write it down, 42 feet. And lay this just to make it a little easier to see. Back sight on the one behind us. And we're going to shoot to this little one right on the ground there. Press down hard on the paper. Come on over here and take a look. Oh, camera. Now if you'll notice, I'm using this extension so I can look down. From this point to where this splits that survey point there, there's the line. And then you don't have to wind this all up every time either. You can just do it this way. Hold it 0. Pull it tight. Take your measurement, 10 foot 4 inches, and just set it on the ground. Certainly can't get 4 inches on that scale. It's way too small, so just call it 10, maybe a hedge a little bit more. And just focus on me now. Move it to the next one. The short sights are actually the least accurate because it's hard to see. What I'm doing right here is picking a point in the distance that's lined up with me. So when I put it on here, I can line up with that point pretty close. Set the pencil, press on the paper to hold it in place. Get the angle to the next one. Put it there. What was that distance?
10 feet 4 inches.
That's right. So this one here, 10. Come on, pencil. 10 feet 4 inches. And you need to make these lines long enough so you can measure them with a protractor later. And then what's this distance? And they're reasonably close distances. You can just pull the tape measure until it's basically there. And that's 17 feet 2 inches, or close enough to 17 feet. .17 feet. Actually, right there. So this is our actual tunnel. Sight lines here. And we're less than a foot off over that distance probably. And the errors will tend to cancel each other out. Sometimes you go a little right, sometimes a little left. But that gives you a rough survey. A real survey crew uses much more expensive and precise instruments to do exactly the same procedure. You use a transit, which gets leveled, you measure distances more precisely, you measure the angles more precisely. The actual procedure is identical, except they write down the notes and then they do the drawing later, usually on the computer nowadays. But this is how you do a survey. You can do it really cheap and inexpensive and still get a good result. Again, the tunnel's not accurate within a couple feet probably anyhow because it just is rough. So let's go underground and see this actually in action and then show you the result. Okay, so we're at the portal here of this adit. And what we've done, we've already surveyed, well, we haven't surveyed it. We've measured it out. And on the way back out, we figured out lines of sight where you can see from one point to the next, to the next, to the next, so that you can go around the curves and always see the next survey point. Now this one here, as far as I can tell, lines up with that one there, and that is due east of this point here. Now, we put 0 on the tape, measure it out, and we have another point of the ground, which I've now set the Home Depot plane table on. You can come with me, little one. Now, here you can see a line with a hash mark. And that hash mark is at 48 feet, according to scale from that. I'm doing 50 feet per inch. And should be lined up, if I can see now, with that. Where the tape is sitting. Yeah. Now, so at this point, this paper is lined up with that line. That point is that distance from the portal. And now Eva's going to move down to the next point in our quest to survey. Now this is the tricky part. An actual plane table is designed to be pretty stable. This is anything but. So now I'm going to move this to that point and sight along it. Okay, so that's pretty much lined up with Eva. Now what I do is simply draw a line. Well, the underground sketch map got a little wrinkled when I threw it away. I forgot to videotape it. But anyhow, here's the actual tunnel. These are the points we were setting the buckets up at. Back sighting to the one before. Shooting ahead. That's why these lines are so long, so that I can actually measure them with the protractor. And when you take all of this information here, the distances were measured directly, the angles were just drawn on the map and then measured off the map. This is what we get. Then I've taken this, I drew a construction line here because I wanted to do something a little nicer. This will be the final map. This will diagram the adit in terms of geographically. This one I'll put in all the various things, the cutouts, the sample points, stuff like that. And so you'll have both on one sheet. So here's the final result. I've done two things in parallel. One is the exact scale model of the sight lines that we did. They show the degrees and the distances in case you ever need that in the future. It's been duplicated here. Here, these are descriptions of structures. For example, this is a stope, here's a dog hole, there's a decline, here's the crosscut at the end with the red vein. These would be the descriptions of the features. These are the actual samples that we took. You know, it's 355 and 370 composite vane 12. It's both ends of this stope where I could get to it. Short decline, 320 feet in. It's vane. I think it's the main vane. If not, it's kind of parallel right there. 6 inches wide. You want to describe where it is. That's your depth in. What type it is. This vein means main vein. This is limonite cross vein here. Okay. And you also want to generally do the width of it. So if you're trying to figure out tonnages and economics. So that is a simple diagram of the drift. It's not real artistic, but it does everything that you need. You can easily go back in there and find where those samples were taken, locate them very closely, very quickly, with the hash marks on the walls and everything else. So that's how you do a simple diagram of a tunnel. Cheap, easy, and relatively accurately with simple hand tools. Protractor, ruler, clipboard, some buckets you need anyway for the samples. Happy prospecting, and keep it safe out there. Lined up with Eva. Now what I do is simply draw a line.